to learn on this digital logic. So over here what you're going to learn is on digits, logic level and digital waveform. This is still on the module 1, so I hope it's still just a basic, so you're going to do more understanding on the basic things. So please focus. So over here on the binary digit and also logic level, you have basically digital electronics circuit that have two stages which are represented by two different voltage, which is high, normally we call as on also, which is bit 1, and then low, sometimes we call as off, it is bit 0. So over here, this is the example of digital signal. Of course, you have 1010, which is representing as the base 2, which is binary. So the binary numbering system is used for digital, and you can see over here also you have high and low, and there is no or invalid if it is in between. So normally it is only 1 and also low for 0. So over here you can see that a bit can have only a value between 1 or whether it is 0 or a 1. So you only have the possibility of 2, high or low, 0 or 1, and on or off. So over here, digital waveform change between low and high level. So the positive going pulse is one that goes from normal, low, to the high. So after this, you're going to look the positive and negative of pulse, and digital waveform are made up of the series of these pulse, because you have positive pulse and also negative pulse. So next examples you're going to look into it. So this is under a positive going pulse. How it look like is from low it will go to the high. So from high, of course, you're going to low, but this is the process, which is it will change from low to high. You call it as positive going pulse. Is it clear? So you have a low and high. So from low to high, repeat again, and you need to remember this. For positive, the high value is 0 and low value is why I miss up between 1 and 0. So okay, I repeat again. Please remember this. For positive going pulse, you can have the high for 1 and then low for 0, because for the negative going pulse, it different in this one. So over here, let's look into negative going pulse. This is negative low going pulse. This is what I mentioned is different. For negative logics or negative going pulse, the high is 0 and low is 1. So you can see the difference now. Positive logic or positive going pulse, the high is 1, but for negative logic or negative going pulse, high is 0. Same goes to low. Low is 0 for positive and low is 1 for negative. So how the negative going pulse look like? It's changed from high to low. So this is the process of negative going pulse. If you can see, the pulse is look like this, which is from high to low. So I hope that these two passage you understand already, because only two, which is positive and negative, and it's very easy to remember. So next, you need to know also on the symbols. If you have the active high, the symbol will be like this, while if you have the active low, the symbol is look like this. What is the difference is on this bubble only. So later on you're going to learn on note get. So there is bubble over here or here. So later on you will see basically where is it and how the symbol look like, but it will be like this one. So if you have this bubble, normally you're going to be not, because the normals I think later on you can see it, because you're going to mess up everything. So just proceed first on this fish, which is this symbol is positive or high, active high, and this one is negative or active low. So what is the difference between these two is there is a bubbles at these sections. So is it okay? So next we move on the digital waveform. So only two type also, because last time we have two different between positive and negative. Now on the waveform you have also two types only that you need to remember and understand, which is there is a periodics and also non-periodics. So what is the periodic means, which is the signal keep repeating after period of time. So you have like a sequence of similar signal. You repeat the similar signal. Let's say you talk yes, 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 yes. So it is repeating, and the signal wave also similar, but of course it is on the digital. You cannot have the voices to be a digital form. So in the digital you repeat the similar wave or similar signals, so it called as periodic. So you can see over here you have this kind of signal. So after that, if let's say you cut and paste like this, you paste it over here, you have it similar, and you repeat all it periodic. So if you have this kind of waveform, you need to have, or you must have, a period and also frequency. Of course for periodic you have also sometime on the period, but you are too difficult to calculate it, especially on the frequency. So on the non-periodic it's very hard to have a period, because it's not simultaneously, and also not simultaneous, it's not repeating, and it's quite to calculate the period and also frequency. So that's why you will have the period and frequency only if you have the periodic signals. So now you need to remember two types of wave or digital wave, which is periodic, and another one is non-periodic. You can see over here for non, so you didn't have the sequence repeating, so it's quite different. You cannot match any time over here to be a repeating of periodics. So next, this is another examples. I give you a few examples on periodic signal. You have this one is on sines. You have basically, if you go over here until this one phase, you have these similar types of signals. You pass it over here, you can get this similar. So it is predict. Same goes to this square, and then triangle followed by the sawtooth. And then the example on a periodic signal. You can see over here, although you have motions of time, but you cannot basically calculate because all the signals are different with time, so you cannot calculate the frequency. So this is the example, 3 examples of signals of the periodic. So over here, this is the equation. I think this one you already learned in your physics for your SPM, I think. But if you didn't take physics, still you learn it for in your science class. So it's quite easy because you just play around between frequency and also period of all time. Period normally in second, and hertz is normally frequency normally in hertz. So two type only, which is frequency, it's on hertz, Hz, and then for periods it's normally in second. So over here you can see how it's correlate to each other, which is F equal to 1 over T, which is your period. Same goes to your period. It is period or time 1 over frequency. So quite simple in equation. So I hope you can remember this simple equation because you also already learned it on your I think form 4 or 5. So next is another examples on how you calculate. So there is a example. You were given the frequency. Later on you can try to calculate it by yourself. If you have a frequency, you can calculate a period. So over here, period, which is 1 over frequency, and your frequency is 100, so you get 0.01 second. So you can also convert it into mathematical formulas, numbering formulas. You will get it 10 millisecond. So so you get a millisecond. So millisecond is -3. So later on you will also learn on the numbering system. This one you will refresh back because all of this is mathematical form. You already learned it on your school. So here the examples of oscilloscope. If there is no MCO, there is no COVID, you can go to the lab, and of course you will play around with the lab using the oscilloscope devices, and you can see a few examples of square form, how you can generate it on your oscilloscope. And this is the example of square wave, and this one is on the sinus waveform. Quite simple, isn't it? So next, this one, which is I already mentioned, this you're going to learn because this one is just a conversion of your mathematics numbering. So you have over here on your kilo, mega, giga, tera. I do believe that you're familiar with this because normally if you want to buy a phone, you're going to look on how big your phone capacity or space. Normally it's on giga, isn't it? And if you play around with the hard disk, your pen drive, you like to buy a bigger size, which is currently it's up to terabyte. While for the smaller, you have the milli, and then you have micro, and then nano and pico. So it is quite similar, because you have 3, 6, 9 and 12. So the flow is quite simple to remember, but for the kilo, mega, giga, tera, it is positive, and then for milli, micro, nano, pico, it is negative base, which is -3, negative the power of 6, 10 the power of -9, 10 to the power of -12, and so on. So over here is the metric conversion chart. You can have this basic, how you going to calculate it. Just simple, but because this one is more to mathematic term. So I give you the example, which is for your frequency. This one you already looked, which is part until this, isn't it? For this example, because this one is 100 hertz, similar, right? Oh, this one is 100 kilohertz. So if let's say you were given a 100 kilohertz, you know that kilo is 10 to the power of 3. So this is it. So you have 1 over 100 times 10 to the power of 3, and you get your answer is 0.01 millisecond. So you can also convert it to another, which is, let's say over here you have milli, and then you have micro, so you have it's 10 microsecond. Please try. Let's say you have frequency of 20 hertz. What's you going to get on your time? You play around with the equation, try to give as many F frequency to yourself, and then you change it. Let's say you have given the time and you try to find the frequency. Try to do your exercise by your own. So over here you were given the examples on the equation of cos and the tables of conversion. Now there is exercise. I think these notes were already given, I think last week, so last 2 weeks, I forgot when, but of course after you were given these notes, you go through all the exercise and please try to find the answer of all these exercise by your own. So there is a solution on that, how you're going to get by using the converter or conversions, just in seconds. So you get the answer if you are given the times and you get the frequency. So this one is just mathematics. I hope that you will try by your own, because if you don't have basic, you cannot go to the advanced level. Now also another examples, but you need to find the time or the period you were given the frequency, so just change its value. There is also another, this one is the answer. So over here on a pulse, you talk about pulse, about your own pulse, but what is a pulse? So pulse is a rapid, which is transit change in the amplitude. So over here, let's say on the pulse, you can see in this signal you have the pulse width and then of course you have the amplitude, and then you have the rise time and fall time. So what is basically, it is measure of the durations of the pulse for the pulse width, this one. And then the rise time and fall time is measure of how fast the pulse change. So from here to here, how fast the pulse change. Same goes to here for the fall time. So you need to know what is pulse definition. You can go through those slides also. And over here you can see there is a repetitions of pulse waveform. So over here you have the amplitude. Basically this is your amplitude, we call it as A, and then your pulse width, which is TW, and the duty of cycles, which is basically duty cycle is the ratio of TW to T, which is on your time. The examples over here, so this is amplitude, as I also draw it, I mentioned it. And then over here, this is your pulse width, and this is the periods, because you need to have one signal form, waveform, and this is the duty cycle from over here to here. So over here you can see it clearly. So this is the part you can see over here, this, and it is over here. So duty cycles is the fractions of time that the system is in an active stage or it operated. So you need to calculate it by your own. So it gives you the equation, which is duty cycles equal to TW per T. What is TW? You were given this in the previous slide, which is plus pulse width, which is TW, and also your T as the period time of 1 cycle. So you are given the example, and please try to calculate. Don't check the answer. Don't check the answer yet. Just try to calculate it by your own using the equation given. So there is also another example. I don't want to discuss on this because this is the example of your own. Please try it, because you need to remember by your own the equation. You were given the time, and also over here the duty cycle, so the duty cycle you were given, and also the time, so you need to calculate it by your own. And normally in your test, in your final exam, please show your works. Please show every step of your work until you get the answer. Don't just simply, let's say your brain is like a calculator. You can calculate by your own. You're given only the numbers and tutap, and then you can get the answer directly, and you just write the answer. No, you will given only, let's say this question you are given 3 marks, but you just write this one, you will get only 1 mark, although it is correct and the question is 3 marks, but you did not have any step on how you calculate it step by step. So every step, let's say over here this one, and then this is another one, so the total is 1, 1, 1. You get the total full mark is 3. So please make sure try get yourself familiar with writing the step of each calculations that you been asked for. So next is this one is just answer for your exercise. This one also similar. Please try it. You were given everything here, the questions, and also on the equation also you were given on the previous slide, so please just check it. Okay, timing diagram. So a timing diagram is used to show the relationship between one or two or more, sorry, not one, between two or more digital waveform, because if you have one, how you can correlate or relate from other signal, isn't it? So you need to have two or more digital waveform. So over here you are given the signals of clock, and then you have another signal A, signal B, and then signal C. You need to do a timing diagram on the relationship. So you can draw the dotted line over here from your clock first, and then let's say you start from here, you have one complete let's say like this, you have one complete cycles. So you draw the dotted line first, and then you can see that there is a correlation or relationship between signal A, signal B, and signal C. So same goes to here and here. All you can have this. Let's say you were given the frequency, and if let's say you were being asked a question, what is frequency for signal A, you need to figure it out by using this timing diagram method, because you know basically what frequency is the clock. So if you using this timing method, you can also know what is the frequency or time period for signal A, signal B, signal C, of course. So let's say you have 1, 2, 3, 4, 5 until 6, and for A you can see over here on the 0101 the coloration. This one is, let's say you've been asked about timing diagram, you've been asked what about what happened to time 6. So you can see what is the value for signal A, which is 0, and then for B it is 0, and then for C it is 1. A, B, C. So this is a timing correlation or relationship. So there is examples on at the 8th time, which is you have A, B, C is low or 0, 0, 0, and then there is another examples on like this timing diagram. Bit time 7, you have A 1, 1, 1 or high, and then another one is bit time 3, which is over here. You can figure out is 1, 1, 0. So you can have bit time 1, bit time 2, bit time 4, 5. Try to figure it out by your own how to correlate using this timing diagram. So timing diagram, you can get the frequency or time. If let's say you were given the frequency for your clocks, you calculate it, but I don't want to show it here. This relationship, I just want to show on how you get the high value or low value. So here you have the truth table. So later on you will learn on truth table of the logic gate. So now you have the timing diagram for signal. So you were given the clock, time 1, time 2, time 3, until time 8, and you were given the truth table. So you need to complete it by your own. So I give you the examples on time 2, which is over here. You have A as 0, B as 1, C as 0. So you complete it 0, 1, 0. And then I give you another example. Let's say at I love 7. So I go to number 7. So A, I get it as 1, and then B is 1, and C is also 1. It's all in high. So 1, 1, 1. Oh, not answer because it's already written here. So try to complete it at 4, 5, 6, and 8. It's quite simple. And about data transfer, basically your computer just understand the digital wave, isn't it? So you will have 0, 1, 0, 1, 0, 1. So that data can be transmitted by either serial transfer or parallel transfer. So either in this form, which is a serial, you have 1, 0, 1, 0, 1, 0, 1, 0, or a parallel data, which is you have 1, but parallelly you will send it with 0, 1, 1, 0, 0, 0 all together in one time. This one is the model we receive 0 first, and then followed by 1, and then followed by 0, and then followed by another 0, and then followed by 1, another 1, 0, and 1. So it's continuously follows. But for the parallel transfer or serial parallel transfer, you have all data in one time. So what is basically a system that using this is basically on printer, and on the serial data is normally on the modem. So I think only that for now for this video, and later on I will share another video which is related to logic operation. But this video is basically from the slide original from our School of Computing. So later on I will also give you another video which is I made it similar like previous introduction to digital logic. I want to make another different type of video, but it is cover all about data transfer, about our timing diagram, about the duration, frequency, time, duty cycles, and etc., which is related all of this in terms of different scenario, different example. So you have many resources, and it will increase your knowledge much more compare if I just give you one video, one slide, one notes, which is all from these resources. So your knowledge is quite small. You just compact it into one resources. So that's why I will make another video that touch all this section, all this topic, but in terms of different view, different examples, and I will add different point and also information. So I think only that for today. For this video, later you're going to learn on digital logic. It's quite simple because this is just a basic logic you're going to learn on logic get, logic basic logic, which is not, or, and, and then after that you're going to learn on exclusive gain and etc. So just until here. So take care and thank you for watching.